Hello, everyone. I believe we are live now. Welcome to the second webinar for the second project. This time we will be focusing on the second part of the project, which will be building a command line app for training a neural network and another command line app for doing the prediction on a given image that you get. Uh, just give me a second. Let me. This one is reading. So sorry, I wasn't expecting that for sure. So how we're going to start? We're going to start by building the prediction app. I'm actually going to show you how the training app is done. Then we'll do the predict app. These are both command line apps, so which means they are programs built in Python, but they are run through the terminal of your computer, through the command line of your computer. We'll be using command line arguments for these programs, which something that I'll show you in a second. So let's get started. Let's get started because we actually have a lot to cover. I'll share my screen with you right now. And we're sharing the screen. So where to begin? Yes. First, I want to show you something from the previous part, which is this. What I had not shown you before, which is if you look at the first part of the project, you actually have this code that they tell you that contains the names for your flowers. Well, this is the catch to name. It's actually a dictionary that you get to load from the JSON files, something that Udacity prepare for you to make easier for the prediction on the prediction part. So this is the given code. You just run this code, and then you're gonna use this code for getting the true name for the flowers. Actually, let's take a look at what it is. As I told you, this is a dictionary where the key is a number. If you go to the folders on your project, you'll see that this number is actually the name of the folder that PyTorch is getting. So you use this number to access the true name of the flower you're getting the projection. And why I'm telling you to use this because we have this guy. Well, when you get the prediction, imagine that you decide to get a prediction, the top 5 predictions. What you get is a dictionary that looks like this. Is it no? I'm sorry, not a dictionary. It's a vector that looks like this, and this is actually those keys that we just saw on the dictionary. And all we have to do, we have to get the true name of the number 1, the key 1, and we do that by running this code. This just a compact for loop. This will do a for loop on this vector, and each element will be x. And what we do, we get this dictionary where x is the key. So by the end we'll be getting five elements of this dictionary, and this will be the names of the flowers. So imagine that you got a prediction, and the prediction look like this. So you tell you there's some the highest percentage belongs to the number 1, the second highest to the number 34, and so on, the third to the 40. And you want to know what the name of the 40 is. You run this code, and here you have the name, and I will have the true labels for your flowers. Just wanted to cover this because this is necessary to actually get to know true names of the flowers. Otherwise, you just have 1, 34, 40, and you wouldn't know the true names. And it does give you this file just to make sure the prediction, and this is how it's done. So you actually get to implement this code by the end of the by the end of the project. I'm sorry. So let's move to the second part. I'm so sorry. Just to the second part of the project, which is the command line app. So when you navigate to the second part, you get the requirements for your command line app, how the usage is, and be on this second in here you get to implement, as I said before. I'm sorry, just close this. So when you get to implement, you'll be using the terminal. When you start, there will be no terminal, so you have to open a new terminal. And you actually will get these files open, but they're not here. So as I said before, to create a new file, you have to come here and create a new file. You need to create the file predict.py, train.py, and then you close the files that will be open, and you get to open them here and here again. And now you will be able to edit, and you'll be automatically saved to the file, and you'll be able to run. So I'm not going to run right now because I already have code on them. So let's start by going through the project file. Oh, as I said before, the hard work was done. We have done the hard work on the first batch. Now we just have to split the functions into training functions and predicting functions which prediction. We're actually going to define a few new functions because what they are requiring. Well, if you look to the requirements, that's the argument for getting arguments from the command line. What this means is that you let me create a test file for us. I'm sorry, do I have a file? No, I don't have. I'm creating just a test file. So you'll be using this library to get arguments from the command line. As I said before, this is standard Python. This is how we instantiate the main function. Would be the main function on a C program, something like that. So basically, what it means is that above here you do the imports, and you create functions, and here you define code that you have to run. So you define the function here and run it down here. So what this actually pass does, it allows us to get parameters passed through the command line like this. I'm just going to pass an argument. I mean, if you need training, there is a lot of training on the. If you click here, you get to. There's a few reference to training. If you need training, if you need to know better what this is, just I'm going to show you right now. Well, with these arguments, we're able to pass the strings through the string side of this program without actually getting something from like input. I'm not gonna read from the keyboard using input. We're actually gonna pass in arguments, and they are passed using this argparse library, and you add the arguments that you want through this command add argument. So I'm gonna say I need this argument. This is a required argument, as you'll see in a second. and I want to print this argument to see that I'm actually passing an argument. I actually have to get this. This I get to pass through this variable all the arguments that I passed. I could have multiple arguments, and I will have in a second to see how. And the name I gave to the argument. And how do you run? I actually have a terminal, and this is why it means command line, because I'm on the terminal, on the command line, and I'll be running the program. As you can see, from issue an error to me because I did not pass any argument. And what I want to do is I want to pass an argument. And is how you pass arguments to be used inside your program without using something like input to read from the keyboard. We don't want to read from the keyboard. We want the arguments we pass through the argument through the command line through arguments, and that's what this argparse library helps us to do, because they help us to organize what arguments will be required, what arguments will be optional, what arguments are just a boolean, and we'll be seeing that in a second. And let me show you how the train.py is implemented. So here we have the train.py. Let me maximize this window, and I'm actually gonna lower it down because we're not gonna run this file. It will take too long to train a neural network, and we actually have a limited time because I have to explain all this. So if you look through the requirements for the training for the train.py, they only require arguments .dir, and the rest of the arguments are optional arguments. For example, this double dash means that the argument will be optional. The user may or may not pass. If it passes, it's gonna have to do something like which means that this is the argument that is passing, would be this argument, and they can actually send this argument in any order they want, because they have to specify what argument they are doing. But this one is required. We don't see these double dashes in front of the name of the argument, and it means that it's positional and it's required, and it has to be the first argument always. If it's not there, the program will fail, and we actually want it to fail because it means that user is not passing any argument, and it's not supposed to work, of course. So this will be the only required argument, and if you look through the requirements, you see that you have the arch to choose the architecture from the architecture that you want. It could be DenseNet, it could be ImageNet, it could be GoogleNet, it could be the ones that we're actually using, mostly using on the first part. So this is an optional argument. You actually can pass this SaveYear optional argument, and this learning rate argument, and this hidden epochs, and GPU is actually, this is the one that is different. It's optional, but it's actually just a boolean. So this is what this sort through action says. So for the user to pass this argument, it's gonna just run GPU. It doesn't have to write anything later after that. You should not, the user should not write anything after that. And this will mean that the argument will be passed, and this value will be set to true when we actually get it from later. If the result does not pass, this argument will be automatically set to false. This is a boolean, so this is the only different argument that you have. So I'm actually using functions to doing everything. So I define this function to get all the arguments that are on the requirement. Once again, the requirement will be detailed here on the second part. And I am here on the actually creating these functions. So I did a function to get all the arguments, whether they require it or not. Once again, if the argument is not required, it has these two dashes. The user may not pass it and the program will not fail. That's why we have these double dashes. And this one, if the user does not pass, it must always be the first argument that the user pass. If the user does not pass this argument, the program will fail. So I just created the function to get all these arguments and will return these arguments. And I just copy and paste basically I copy and paste the transformations for the training, and also encapsulating it inside the function to get the training data. This will return me a training image folder. I'm taking an argument which is a string. As you can see, I'm using this string to get the name of where the files will be, where the images will be. So, and I'm doing the same thing for the test transformations. I'm also encapsulating all the transformations we did in the previous section inside a function and returning a image folder. And now I'm using a function for getting a loader. Could either return a turning loader or a training loader or a testing loader. So if it is a testing loader, I'm not, which is here, I'm not doing any shuffling. I don't need to do any shuffling. If it is a training data loader, I'm actually doing a shuffle to, once again, this shuffling, this randomization. You can see we use randomization for the training transformer, but don't use for the test transformer. We use this randomization to help the neural network to generalize better. So we do these random rotations, random cropping. This will help the image to see very different images. And we don't do that on the training, on the testing, I'm sorry. We do that only for the training. And here I have the data loader, and you can use to load either from, if you pass either a test data folder or a train data folder, you just have to specify which one you're passing, so you can use shuffle. And I'm defining a function to check for the GPU. As I said, this argument is using to when the user wants to say that he wants to do do the training using the GPU. So if the user pass the argument with this dash GPU, set this argument to true, it means that he or she wants to use the GPU to do the training. And this is what I'm doing the checking, because we also have to check if the GPU is available. So if the user does not pass the argument, if the argument is false, we just send it to CPU. Else we check if the CUDA is available. If we are on a GPU workspace. If we are not, we're just gonna return a CPU. So even if the user pass the argument and say that he wants to use the GPU, we will give him CPU if GPU is not available. We can also fail this program. Say you're requiring something like you're requiring GPU, but the GPU is not available, so we are exiting the program. It's not going to train anything. So, but we're not going to do that. We're going to continue to do the training, but given that we do not have the GPU, we will be doing the training on the CPU. This is standard code. We have discovered on the lessons, so just encapsulating these inside functions You're gonna see why I'm encapsulating everything inside functions in a bit. So if the device is CPU, I'm gonna give a warning to the user, printing that, hey, uh, you're not say that you are using CPU training. Yes, and we actually say that we in this function is done, just for checking if the CPU and returning a device, whether it's a CPU or a GPU, just encapsulating everything inside the function. And we have another function for defining the model that we're gonna use. Could be the dense net, it could be the could be the VGG16. I believe most of you are using the VGG16 because Udacity told you to start from using the VGG16. Well, the VGG16 is an awesome model, but you can also try to use another model like, for instance, using the DenseNet if it is available to you. So I mean, if you have time, still have time left. As you can see, I still have 52 hours. I actually tried both models, and actually the VGG16 performed better after six epochs of training. So what we're doing here, if the user does not pass any parameter, once again, this is an optional parameter we're going to receive. The user does not pass this, we're going to give in the VG16 model, which should be the standard model. As you can see, this is the extender. But otherwise, we're going to do this exec. And what this does is it turns this string here, into into a line of code. So even though it is a string, we have to find a way to make it just a line of code, and this is what this exec function does. And if you're curious about this, this is just formatting the architecture that the user passed. I mean, if the user pass DenseNet, this would just be replacing these curly braces with the architecture that he chooses. So if passes DenseNet, this will be this string will actually read model equals model dot DenseNet pre-training equal true, and this will be executed as a normal line of code. This is what the exec does, and let me show you again what it is. I'm gonna be running Python on my terminal. So so imagine that I have this string, which is let's say there is a print. No, let's say there is hello world. So this is a string, but I want to make it executable. This is what the exec function does. So if I run exec on what I get is this code. This string would be executed as if it were a code, as if it were a piece of code, but it's not a string. And why we need this? Why we need this exec function is because we do not know what model the user is going to pass to us, and we still want to make it executable. So you actually have a modern way to do this. This exec will execute any model that the user may pass, and you could actually do this through if else. So you say if architecture equals this net. Write by you write a code by hand, like model equals models dot but imagine if you had to do this by hand for each model that is available on PyTorch. I mean, it would take quite a lot of time. It wouldn't be elegant code because you have to reviews to keep saying if, else, if the architecture equals DenseNet, then run this. If the architecture equals VGG13 equals this, and it will take a lot of time. What we moving on, we have this exec that will execute this line of code as if it was a line of code, and will give us this model. Given, of course, that the architecture is not given was not null. If it was none, which means the user did not pass this, and it actually is um, an optional argument. So the user may or may not pass this the architecture. Does not pass, we're just going to give him the VGG16 as our standard. If not, we're going to run this code, and we're going to execute this line as if it was a line of code. This is what this exec does. And we're going to give him the architecture that he's asking for. And we're doing this, once again, we did this on the previous lesson. What this does, it stops the training for the whole model. And once again, we will be replacing the classifier because the model does not need training because the model was trained on the ImageNet, which is a data set over 1 million images. But the classifier actually needs training because it needs to be trained for all data sets. So we set false to everything, and then we replace the classifier with a classifier that actually has this requires guard to true because there is a standard. So this is what we are doing here. We are defining the initial classifier. We passing a model, the model that we got from here. So whether it's the VG16 or the DenseNet or any other model, we actually be passing on this to this function. And this function will get the model and the number of hidden units, which is, if you remember correctly, this is another optional parameter that the user may specify. The user does not specify, as you can see here. You're gonna just set to 2096. We don't care. Just the user did not say how many hidden units he wants, so just gonna give him for 4096. Actually, you can choose this any number you want. This is not mandatory. This is just a number that I decided to give. I could pretty much decide that we're gonna give him 2000 or 3000 hidden units. Doesn't really matter. What is necessary is that we will use it correctly here. So here we are defining a classifier. We're gonna get the input features. The input features may vary because we can have any model that is available on PyTorch, and the way to get the input features of the classifier is by running this code, which gets what the input of the classifier is, and it stores inside this input features, which is actually a number, and we use this number for defining the classifier. So the classifier will get the input features, whatever it is. Maybe I don't remember how many are for VG16. Imagine that VG16 actually has 2000 input features on the classifier. This would be 2000. Would be passing to the hidden units, but I believe it is more. I believe it's more. It's like 20,000, something like that. Be passing to the hidden units. The hidden units is here. We pass it to 102. We actually instantiating this classifier for doing the training on for doing the classification on the flowers, because if you see the classification, it does not tell to to what problem we're solving. We're assuming this is about the flowers problem. So we're sending this to the 102. If you remember correctly, 102 is the number of classes on the problem of the flowers. And at last, we're passing the log sort max to the to the output layer, and we're getting classifying. And now we're returning the classifier, and this function we will return as the classifier that we will be replacing the classifier of this model, the initial classifier. So we are defining, this is pretty much copy and paste from the previous session that we define a validation function, and this is the validation function, which takes a model, a test loader, a criterion, and a device, which could be CUDA or could be a CPU, and this runs the validation. I'm not going to run through this in detail because this is pretty much the validation function that we defined early on the previous webinar. And this is the trainer for the network, the function for training. We actually also defined this on the previous webinars. I believe 2 webinars from now. I don't know, it's on our past webinar. So this is basically defining a function for training, for doing the training. This is covered on the lessons. So if you have any questions, you can check the lessons. Please check the lessons because this is pretty much what the lessons are telling you. So yeah, instantiate the same function, just copy and pasting for training. And once again, take the model, the train loader, and the test loader for validation. And if you look through this, we'll be running the validation function, this function, inside this function. That's why we define this function earlier, because we'll be using this to validate your model. What else? This is for validation model. It's another function for doing the final validation. This is for the test set. I don't even know if we need this. Maybe we could use this function. I don't know. I don't remember why I implemented this, but nevertheless. As you can see, I'm also using the model to the eval when I'm evaluating, because I'm going to be doing training and just be evaluating. And as you can see here, I set the model to training. I believe this code even is not very useful actually. So see, I'm setting to eval when I'm going to do validation, and I set to training when I'm going to do training. I'm sending it to training again. What else? Then we're gonna do just the same function we have used for saving. We are using the same function, just copying and pasting the function we created on the previous session here. So it takes a model, a save G. Save G is where the model will be saved, the file name. So in the train data. So what I'm saying is that if I do not get the, I'm sorry, just it's got a little incorrect. So oh no, it's correct. So if this is I have to erase this. I'm sorry, this line is just a print. Don't need this. So we pass the save to the model, and will be saved here using the. Actually, I was doing some training, so. I'm just saving the file to whatever file name the user. This is actually also an optional parameter. If the user gives you this parameter, you save it to this I'm sorry, where were we? Sorry, here, way back. We save to this name that it gives you. And this train data is just to get the class to AJX as we did before on the previous session and attach it to a model. And here we're just saving a model, just giving the architecture. This is pretty much it's pretty standard code. So the same code that we did before, just copy and paste again. And now we're going to define the last function. What this function does is, I'm sorry, I was running this code for training, because if you go in this folder, you see that the flowers are here. So if you want to train, you can just set this strategy to use these flowers for training, and this is what I was doing. So the data geo is actually a required argument, as you recall. This is the name of the argument that we return. So what this main function does, it just uses all the previous functions that we defined before, and it does the training of the model. So it takes the arguments, and it defines it gets the train, the test, train transformers, the train, the validation, and the test, and it gets a data loader using these guys. It uses the function for loading a model. As you can see, we're passing the arguments arc.arch. So if this arc is null, we're gonna use the p16 as we discussed it before. And we will also use the function for defining classifier. Yeah, actually using this model here, inside here, to get a classifier, and we're replacing the classifier of the model, just as we did in the previous session. And we're changing the model to whatever device we have available. I mean, maybe the user is asking to train on the CPU, what will actually take a lot, but this is the user choice. But if the user actually pass the flag when he tries the function, when he runs the program, this would be what I'm simulating the working of a program. I'm not going to run this because it will take too long. I have run this, it is functional, and as you can see, I have created a checkpoint. I have already created a checkpoint. I have already done the training and created the checkpoint here. So if the user passes this flag, this will be a device, be signaling that he wants to use the GPU, and as we discussed before, the GPU is available. Yeah, we give the user the training on the GPU. If the GPU is not available, we will do the training on the using the CPU. So what we're doing is the same thing we did in the previous session. We define a criterion for training and optimize it for training. And we're defining a print every and starting the steps, and we're using the function for training to train your model, and just warning the user that the training is complete. And then we're running some validation on the model to see how it is performing. And at last, we are defining a save dir. It defines this function has the save dir, and if the save dir is different from none, which means if the user actually passes a save directory on these arguments. Let me show you again these arguments. If the user actually passes this optional argument, we are gonna replace this as we call it this standard argument, and we're gonna use what the user told us to use, and we're gonna do, and that's pretty much it. And after this name equals main, we're just calling the main function at the end. So what this does, it calls this main function, and inside this main function, we have all the behavior of training that will call all the previous functions that we have defined, all these functions that we have defined before. It will call all these functions inside this main function, and this main function will be called here. So as I said before, above this name equals main, you define your functions. You define all of your imports, the imports you're going to use. This is our imports for. These are basically the same imports that we had on the previous Jupyter Note on the previous session when we were doing this on the Jupyter Notebook. And after running this will run our program, and pretty much we're done here. This program will behave as was required here, and we'll do the training. And I'm sorry, just we have done the training program, the training command line app. So this command line app will do the training. Now let's go to the predict app. And this app will just do the prediction. Once again, we're doing the importing all the libraries we're going to use. And we're doing some arg parse. Once again, the arguments are specified here. These are the actual arguments. So we actually have a mandatory an image. Of course, what we're going to predict if we did not have an image. So it's mandatory for the user to pass this image. It's mandatory for the user to pass a checkpoint of a network that was trained. And all the rest of the arguments are optional. These are positional arguments, which means you have to first pass the image, and then you have to pass the checkpoints later. The second argument must be the checkpoint, and the rest is just at your choice, just at your discretion. And once again, we're doing a function for wrapping everything inside a function, parser function. And this is the function for loading the checkpoint. This is the function we have defined on the previous session. Once again, we just have to maybe copy and paste from the previous function, from the previous section. We have defined this function in the previous section. So once again, we're checking if what the object architecture is. This is actually redundant. All we actually need is to load the model. I think yes, we're loading the whatever checkpoint. I'm sorry, just gonna send it here. Of course, this is wrong. Have to pass the checkpoint. To load whatever checkpoint we pass. And this I'm actually gonna do some coding here. We recall this is how we define the. I'm sorry, this is not a test. On the train. Let's see how we save the model here. This is the model for saving. Save is the name of model. So this is what we're doing here. We're getting the model, and yes, we save as a state digit, and we're loading the state digit. We actually leave this code. we're loading the checkpoint, loading the model, loading this execute, and we are returning the model. And that process image function that we did using PIL, that's why we are importing PIL. We just copy and paste it here. This is pretty much the same function, just have to copy and paste inside this. As you can see, this is the same function. I believe I did some changing, but it's the same behavior. You can just use the previous function on this inside this. Just copy and paste the function. I did some changes just because I wanted to test something, but don't worry. If you just copy and paste the function that we created on the previous session, and you use it inside here, it's going to do the same behavior. So remember to copy the previous function and paste it. And what we're doing is processing the image as we did before. And we're doing the projection, which again is the same function that we did on the projection that we defined in the previous webinar. We define a project function. This is the same function. There's nothing changing. There's no change here. There's no change. It's the same function. And we are printing the probability. Now we're not going to plot the images as we did on the previous function. We're just going to print the flower, what the flower is, and the probability there is this flower. So it gets a little easier. You don't have to use SNES for plotting. You just have to print the probability. And once again, we'll define the main function to call all of the previous functions. Once again, we're getting the arguments. The category's name has a explained at the beginning of the webinar. It will be on this JSON, which is a dictionary. But this is also a optional parameter. So if the user does not pass this parameter, which means here, the user passes parameter, we're actually going to replace this. And if not, we're going to assume that this is the standard and that this file will actually be here. So as you can see, I have downloaded the file from the previous folder. The file is originally here. You can see it here. I downloaded this folder, this file, and I use this to upload the file, and I get it to put it here on the folder that I'm running these programs, these command line apps. And I'm using this as a standard. If the user does not pass anything, I'm just gonna assume that I have this file on my folder, and I'm gonna use it to do the predictions. So don't forget to copy and paste it here. To go inside here, download the file, come back here and upload the file. And we're doing the processing the image. We are checking if the GPU is available. I'm not sure, but I believe this is not. I'm not sure if yes, it's also an optional argument as before. So if the user says he wants to use, if not, we're just going to use the CPU. And once again, we are checking for the GPU. Actually, I'm loading this function from the train.py, as you can see here. I'm loading the function that we defined because it has the same behavior. I could just copy and paste inside this function, but inside this file, but I'm not. I'm just going to import it from the string.py because I have already defined it here. I could just copy and paste inside this file, but why to do so? I can just do it and avoid doing copy and pasting. And once again, I get the labels. I'm sorry, not here. We're here. Checking for the CPU, running the prediction function, and just printing what flower it is, what flower we have. and the probability of the flower. This is using this function to just plot that, and that's it. Pretty much we are, once again, we're instantiating this main function. So once again, we are calling this function. They're going to call all the above functions. And by the end of it, we have this fully functional program that's going to do the projection on images. Let's see if I can run this this project program. So once again, what are our arguments? The first argument is the required arguments of flower. I actually have one flower here, which is flower1.jpg. Once again, I have downloaded this image from any of these folders. You can download an image and I just rename it. I have downloaded it and I have uploaded it to this folder, renamed it to use an easier name. So let's see, here. I'm gonna use the checkpoint that I have that I created earlier using this train.py. So project.py, the first argument will be any flower. I have two images here. I'm gonna try to predict the first flower. It will actually not work because I have just changed a few functions, have not tested it. It was working before, so don't blame me if it does not work. And the second argument will be the checkpoint for the neural net that will do the prediction that we did did the training. So let's see. As you can see, the top k default top k is equals to 5, and I have 45% likelihood that is this flower, 27 that is this flower, 17 this flower, 7% this flower, 2% this flower, and that's pretty much it. Let's actually change this. This function only 2. So as you can see, I passed that. I just wanna two probabilities, and I got this too. Let's run on this other flower, the other image, just for checking percentage. And it works just fine. Wow, this model is absolutely correct. It's almost sure that it is this blanket flower. You can see that the numbers are adding up to 101. Don't worry, this is just because of we are rounding this number to this number. One of these numbers is getting rounded, so it actually is 100% divided by this number, so it's okay. So once again, let's go through this predict function once again. We define a function for getting the arguments. These are the arguments. These are optional arguments. These are mandatory positional arguments. Even if I did something like swapping these arguments, it would not work because it is expecting the image to be the first argument, the checkpoint to be the second. So if I pass the checkpoint to be to the place of the flower and the flower to the place of the checkpoint, it will not work. And we want this is the expected behavior. So we're passing all these arguments on this first function. We have a function for launching a checkpoint. We define this function on the previous section. We have this process image, which is the same process image that we defined in the previous section. Don't worry if it's different here, just because I was doing some testing, but if you just copy and paste the one that I help you to do before, this will work fine. This is just what it does. processing the image as we defined on the previous section. And we have the same function that we did use for prediction that we had before. Once again, just some changes, but these changes are not even necessary. I'm just putting these top labels and these top flowers here, but don't worry about this. What else? I'm not even using this. I believe I'm doing it. Don't worry about this. And I have this print probability, just a for loop inside probabilities and flowers that will be passing here. And I'm printing what the flower and the likelihoods. And I'm defining this main function that will get all that will execute all the above all the functions that I defined above. So this is all functions that I have defined for, except this function, which, as you can see, once again, as you can see here, I'm loading from this train.py. So from train.check GPU, this is the check GPU function that we defined here inside this train.py. So let's go back to the main function. As you can see here, checking for GPU using the argument the user will pass, and I'm using the function to do the prediction, and I'm printing, and here I'm just calling this main function. If I had nothing here, I wouldn't be calling a function, and the program would not do anything because although I define the functions, I'm not calling anything. So that's why I need this function here. So I'm sorry, this function that will execute all this code, and this code will be calling all these functions as we have seen before. And we did the prediction. And let's go one last time to the train.py. So once again, we did the imports. We did all the imports that we will need. We define a function for passing arguments. This is the only required argument. All the other arguments are optional. And we define a train transformer that will give us an image folder, and a test transformer that will give an image folder for a test for the test set. And we're doing the data for define a data loader that will take a folder and give a data loader, as you can see here. So the previous part I had this had it apart into these three functions. The first part of the project, I just encapsulating each part on a different function. I define this check GPU. This is the function that we are loading on the train.py. We're importing on predict.py. We're importing this function from here, so it will be the same function. This is just for checking for GPU. We are defining the model using, and we have learned how to use this exec to transform this string into a line of code, as would be this line of code, as would be this line of code actually. So this would just become the same thing as this, only to use exec. And once again, we're freezing all the parameters, and we're defining a classifier using our model. That's why I have to pass our model, getting features. And as you can see here, we are defining this model especially for any problem that has 102 outputs, because the specification did not say that how we were supposed to handle this, and they did not say anything about arguments or anything like that. So we just assuming that this train.py and predict.py will be used for the flower project. and we're returning the classifier. Then we're doing some validation. Define a function for validation. This is the same function for validation that we did before in the previous session. So we can just copy and paste. And we're defining a training function. And I did get through this training function in the previous webinars. That's why I'm not going into details here. But this is the same function that we defined before. So just copy and paste, it will be fine. As long as you did watch the previous webinars and know how this works. This just does the training. And use the validation function to do a validation inside the training. So this validation just so you can know that our model is actually improving after each epoch. So now we return the trained model. We pass the model and we return the trained model, the pointer of the training. We define a function for validation on the test set. And we define a function for saving. This once again, this is the same function that we defined before. You can just copy and paste it here. And we're doing define the main function that will call all the above functions and organize the code. Once again, the learning age is not is an optional parameter. I'm not sure I'm defining it here. An optional parameter. If it's not, if the user does not define, we're gonna set it to this number here. And as always, we define a criterion, an optimizer, and after how many steps do we want to do some printing to check our work, we initiating the steps, the counting, and we're calling the function for training and getting the trained model here, this trained model. And after we do the training, we do the validation of the model. Once again, using the device that the users told us to use or that we have available. And at last, we are saving the model. And below here, we're just instantiating this main function. Once again, if we did not have this function, that we would just be defining the functions without using anything. That's why you have main. So below here, we're just gonna call this main function. And the job of this main function is to execute all this code, calling all the above functions. And after that, we're done. This pretty much gives you everything to complete the second project. Let me get back here. So now we have everything to complete the second project. I wish you guys luck to complete this project. But if you go through the previous 3 webinars, this webinar and the two previous ones, so 2 weeks from now, you pretty much have everything to complete this project. You have a lot of explanation that I believe was lacking from the lessons. And I wish you guys luck on completing this the completion of this project. I mean, it's not difficult now. You can just go through these webinars. You have everything to complete the project. And once again, I'd like to thank you all for listening. And I want to thank you. I think the students that are actually implementing this project, because yeah, I use a lot of the feedbacks to organize this webinar, to understand what was need of explanation. So thank you so much, Matt. You actually helped a lot to organize this webinar, to telling me what was necessary, what was not necessary, what were the difficulties. And once again, I agree with you. This lesson on PyTorch is actually a little lacking. I mean, because the lesson does not explain everything that you need to know to implement. I mean, the PU's usage is not explained well. The argparse library is not explained well. So thank you very much for your help on clarifying what actually needed clarification. And I mean, to the people implementing this project, once again, congratulations. I'd like to congratulate you, because this is not an easy session. And I would like to congratulate that you decide to stick with through the difficulty. And thank you for watching. Anything, once again, any help that you need, you may come to me. But so far, I believe you have everything to get approved on this project. And thank you so much. Until the next time, goodbye.